Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are going to discuss about the chapter periodic classification or classification of elements and a periodic table. From this chapter, today we are going to see about the introduction part. So first let us see what is importance or a necessity for the classification of elements. For example, a medical shop contains a vast number of medicines, isn't it? Have you ever visited a pharmacy? If you go to a medical shop, there you can see so many kinds of medicines and tablets, syrups, and these all, isn't it? The shopkeeper finds it difficult to remember all the names of the medicines that he has. But when you go to the medical shop and ask the shopkeeper for a particular medicine, he hands over it to you without any difficulty. How it is possible? Have you ever observed this? Yeah, now whenever you go to a medical shop, you observe that there will be different lots of medical tablets, syrups, injections, and these all will be there, isn't it? Cosmetics all will be made. But when you ask a particular tablet, immediately that shopkeeper will go and collect the tablets from that box and will hand over you without any difficulty, isn't it? This is happening by the segregation of those all tablets based upon their difference. All fever tablets will be kept one side, headache tablets will be kept one side, and some other problem curing these tablets will be kept in some rack. In this way, by segregating those tablets, it made him very easy to collect those tablets whatever we ask, isn't it? In the same way, if you think of a super bazaar, when you step into a particular arrangement of goods inside it, isn't it? When you look for needed grocery, you can select it easily. And when you go to a supermarket, there you can see the things will be segregated in different manners. All food items will be kept one side, all grocery will be kept one side, and all some other kind will be kept separate. All the items will be segregated based upon their properties. All vegetables will be kept one side. In this way, all pulses will be kept one side. In this way, by segregating those, our work made very easy. We can go to the concerned place where we need the pulses or grains, whatever we need there. We can go and we can collect those, isn't it? In that way, the segregation of materials made them easy, categorizing them easy. So, from the above observations, you understand that for any system involving several things, a particular order of arrangement of those things is essential. Yes, for any system which is containing several things. So, if they are all the several things are segregated based upon certain properties, their understanding and working with them will become very easy. Even in chemistry also, from earlier times, scientists have been trying to classify the available elements into a limited number of groups on the basis of their properties. So, how it is made for selection of medicines in the medical shop, and how it is made easier selecting our grocery from the supermarket. In the same way, the understanding of the chemical elements also becomes easy if they are segregated. So, in the chemistry also, from earlier times, scientists they are trying to classify the elements into different simpler groups based upon their properties. So, there is a need for the arrangement of elements in an organized manner. Robert Boyle defined an element as any substance that cannot be composed into a further a simple substance by a physical or chemical means. Yes, for the first time, Robert Boyle defined that element. He told that element is a simpler substance which cannot be decomposed further into simpler substances. That only the simplest substance of every matter is considered as element. So at his time, about 13 elements were known. Okay, only very few elements were known at the time of Robert Boyle. Towards the end of 18th century, by the time of Lavoisier, another 11 elements were discovered. Slowly, the number of elements discovery became grown. So by the time of Antonio Lavoisier, 11 more elements they have discovered. By 1865, about 63 elements were known, and by 1940, a total of 91 elements, naturally discovered elements, were found, and another 17 elements synthetically were obtained, which are prepared in the laboratory by the scientists. So, but by now, including synthetic elements, there are 118 elements discovered so far. Yes, by this time, scientists they have discovered till now 118 elements. Out of these, there are some synthetic elements and mostly naturally occurring elements. So as the number of elements increased, it became difficult to keep in memory the characteristics and chemical properties of these elements and their compounds. Yes, actually at the earlier days, in the olden days, only few elements were known, isn't it? So the remembrance of the properties of those elements individually might be simple because there are some number of elements less. But later on, scientists they have started discovering new elements. Time to time, so many elements were discovered. How many elements are known till now? There are 118 elements are discovered so far, either natural or synthetic elements. So the remembrance of the properties of these many elements and their compounds a little difficult. We cannot remember those properties simple way. So in previous classes, most probably in 8th class, we have learned the classification of elements into metals and non-metals, isn't it? There you have seen how elements are classified into metals and non-metals, on which basis, and what are the properties of these metals and non-metals also we have seen. For example, sodium, potassium, etc. are metals, isn't it? And sulfur, chlorine are non-metals. But this classification had no limitations, had so many limitations. For example, aluminum has some metallic properties and some non-metallic properties also. So that segregation is not comfortable or is not completely satisfying the properties of the elements, because some elements are there, sodium, potassium, etc. are metals. So there it is okay. Even with the non-metals like sulfur and chlorine also, they come under non-metals. They exhibit the properties of non-metals. But there are some elements like aluminium. It exhibits the properties of metals and certain properties it shows with the non-metals also. So elements of this type are considered as metalloids or semi-metals. For example, there is an element called silicon or germanium. If this is germanium, it exhibits the properties of both metals and non-metals. Such kind of elements which exhibit the properties of both metals and non-metals are called metalloids or semi-metals. Okay, so for this there is no segregation in this metals and non-metal segregation. So the third kind of elements are not segregated properly. That's one limitation we can say. So there was a need to classify them in another way. So this metals and non-metals is not the proper way for classifying the elements. They should be found another way. Hence, chemists started to frame ways to group these elements and compounds on the basis of their physical and chemical properties. Then they have started to find new ways for the segregation of elements based upon their physical and chemical properties. In the beginning of 18th century, Joseph Louis Proust stated that hydrogen atom is a building material and atoms of all other elements are simply due to the combination of number of hydrogen atoms. So this was a proposal which was given by Joseph Proust. Actually it is not correct. But at that time, as they don't know any other elements, so they have proposed, he thought that hydrogen is a basic fundamental or building material of all the materials, building material of all the elements and compounds. So all other elements are simply due to the combination of these hydrogen atoms are being formed. In that way, he assumed. Anyhow, it is wrong. It is to be noted that at his time, the atomic weights of all the elements were given as whole numbers, and the atomic weight of hydrogen was taken as 1. So based upon the atomic weight of hydrogen as 1, it is taken standard and the atomic weights of remaining elements are measured. That's why almost they got atomic weights for the all elements as whole numbers. So based upon these all categories, characteristics, Joseph Proust assumed that hydrogen is a building block or building material of all the atoms, all the matter, and remaining all elements are formed just because of the combination of number of hydrogen atoms. In that way, he proposed in the 18th century earlier. So next, one more scientist, Doverner, tried to classify the elements. A German chemist, Johann Wolfgang Doverner, noted that there were groups of elements with three elements known as triads, in each group with similar chemical properties. So he observed, while studying with the properties of the elements, he observed three elements are having same kind of chemical properties. So he called these three elements as one set and named them as triad. So in the honor of his name, they are called now Doverner's triads. So he is Doverner. He classified three elements as one set and he called those set of three elements as one triad. So they are called Doverner's triads. He tried to give a relationship between the properties of the elements and their atomic weights. So he tried to observe the relation between the properties of the elements and as well as the atomic weights of those elements. Dauvergne stated that when elements with the similar properties are taken three at a time and arranged in the ascending order of their atomic weights, the atomic weight of the middle element is average of the atomic weights of the first and third elements. So what he observed? He observed the elements which are having similar chemical properties, three elements, and he arranged three elements in the increasing order of their atomic weights. Then he observed one more interesting point there. The atomic weight of the middle element in that set of three elements is equal to or nearly equal to the average of the atomic weights of the remaining two elements, that means first and third elements. This statement is called Dauvergne's law of triads. When elements are written in the increasing order of their atomic weights, the atomic weight of the middle element is equal to the arithmetic mean of the atomic weights of first and third elements. This is Dauvergne's law of triads. For example, lithium, sodium, potassium is a Dauvergne's triad. He observed the chemical properties of these three elements are being similar, so he called these as one triad. So on these three elements are written in the increasing order of their atomic weights. For example, if we see the atomic weight of lithium is 7, whereas the atomic weight of potassium is 39, and atomic weight of sodium is, as we know, it is 23. Now the atomic weight of sodium is equal, the middle element sodium is equal to arithmetic mean of the atomic masses of lithium and potassium, that is first and third elements. We take the average or arithmetic mean of these two elements, that is equal to atomic weight of sodium, that is 23. In this way, in all his triads, the atomic weight of the middle element is exactly equal to or nearly equal to the atomic arithmetic mean of the atomic masses of remaining two elements. So here we can see some more triads from the Dauvergne's classification. Chlorine, bromine, iodine. This is one set of three elements which are having similar chemical properties. So here these three are written in the increasing order of their atomic masses. Now bromine atomic mass is equal to arithmetic mean of the atomic masses of these two elements. In the same way, calcium, strontium, barium is one triad. Sulfur, selenium and tellurium is one more triad. Okay, Dauvergne's attempts gave a clue that atomic weights could be correlated with the properties of the elements. So for the first time, from the Dauvergne's triads classification, they came to understand one thing, that is, atomic weights of the elements are being correlated with their chemical properties. So it made chemists to look at elements in terms of groups of elements with a similar chemical and physical properties. So by this, scientists they have started to observe the elements as groups based upon their physical and chemical properties. This eventually led to rigorous classification of elements and the modern periodic table of elements. So this is we can say as starting for the chemical classifications based upon the properties. So nowadays we're able to see one modern periodic table. You might have observed this in your classroom or in your laboratory. That we say modern periodic table. But it was not the first classification. For obtaining this modern periodic table, so many struggles were done. So many scientists earlier to that they have tried to classify the elements. Out of those all, we can say Dobernier's classification was the first one which led to the classification of elements in this manner. So it was a first classification which given an idea about the relation between the atomic masses and the properties of the elements, right? So, but there are some limitations. What are those? Let us see. All the known elements at that time could not be arranged in the form of triads. Yes, he has arranged three elements as one set and called as triads, which are having similar chemical properties. While he was giving this classification, some elements were known, but he was not able to classify those all known elements into these triads. The law failed for very low mass or for very high mass elements. For heavier elements, this law is not being applicable. Masses are being varied than expected. In case of fluorine, chlorine, bromine, the atomic weight of chlorine is not an arithmetic mean of atomic weights of fluorine and bromine. So, for some cases, his law is not being followed, like fluorine, chlorine, bromine. Okay. Next one. As the techniques improved for measuring the atomic masses accurately, the law was unable to remain strictly valid. So with the guess atomic masses, it was being proved then. But after later on, scientists they have found some techniques, improved techniques for calculating atomic masses accurately. Then this Newland Dobernier's triads classification failed. So next, one more scientist tried to classify the elements. He was Newland. So John Newland was a British chemist. Newland found that when elements were arranged in ascending order of their atomic weights, they appeared to fall into 7 groups. Each group contained elements with similar chemical properties. Based upon these observations, Newland proposed the law of octaves. What is that? Let us see. The law of octaves states that when elements are arranged in the ascending order of their atomic weights, they fall into a pattern in which their properties repeat at regular intervals. Every eighth element starting from a given element resembles in its properties to that of starting element. So what he done? He arranged all the available elements in increasing order of their atomic weights. And then he observed the properties of an element in that series are resembling with the consecutive eighth element to it. So as the properties are being repeated with the consecutive eighth element, he called those elements as octaves. So in the honor of his name, they are called now as Newland's octaves. So elements with similar chemical properties are to be present along a horizontal row. Okay, in this way, he arranged a table with the repetition of chemical properties from element to element. The element which is getting similar chemical properties with the previous element, he written down to that. For example, if you see lithium, for lithium, the consecutive eighth element is sodium. If we count from here 1, 2, 3, 4, 5, 6, 7, and 8. So for lithium, the consecutive eighth element is sodium. He found that lithium and sodium both are having similar chemical properties. So he can write down to that lithium here. And from lithium, if it is counted, the eighth element will be potassium for that. So he wrote potassium down to sodium. In this way, he arranged these elements based upon the chemical properties. Okay. Newland was the first to assign atomic numbers to the elements. Unfortunately, his work was neither accepted by his seniors nor by the journals of chemical society, which rejected his publication. Yes, because of the some limitations in his Newland's law of octaves, it is being rejected. Newland's table of elements. If we start with the hydrogen and move down to the oxygen and then start at the top of the eighth element from hydrogen is fluorine and next eighth element is chlorine and so on. The properties of hydrogen and chlorine are similar. Till here it is okay. It is accepted. So he arranged hydrogen first and down to that fluorine and next chlorine. In this way, he arranged elements in one column which are having, as he assumed, having similar chemical properties. It is accepted. But if you start from lithium, then okay, one more example they mentioned here. If we start from lithium, then eighth element to lithium is sodium, and next coming eighth element is potassium, and so on. So these elements show similar and similar physical and chemical properties. So this is also an accepted point there. But Newland's table is not without problems. Even in this also there are some limitations. There are instances of two elements fitted into the same slot. For example, cobalt and nickel. These two are given in the same slot, but both are different elements. One more problem is certain elements totally dissimilar in their properties, which were fitted into the same group. So if elements are kept in one group, that makes that gives information that as these all elements are having similar chemical properties. But in Newland's table, some elements with dissimilar properties kept in the same column or same group. So this also made some confusion. So because of these limitations and drawbacks, this Newland's classification is not accepted by the scientists, his seniors and generals. And even it is completely failed after the discovery of noble gases. So after the discovery of noble gases, this octaves law was no more correct. For example, he arranged cobalt, nickel, palladium, platinum, and iridium, which have different properties compared with the halogens in the same row. So these all elements are kept in one column. Cobalt, nickel, palladium, platinum, iridium, and even chlorine, fluorine, bromine, iodine. These all elements are in the same vertical column or group. He classified them as one column, one group elements, but these all are having dissimilar properties. These halogens are having one kind of properties, whereas these are having dissimilar properties, but kept in one column. This we can say one drawback. Newland's periodic table was restricted to only 56 elements and did not leave any room for new elements. Yeah, this one more major drawback we can say. It is limited for few elements only. Even though they came to know new elements at that time, there are no slots for those new elements discovered. So it is limited. Elements that were discovered later could not be fitted into the Newland's table in accordance with their properties. So there are no specific slots for the elements which discovered later. This is one drawback we can say. Newlands attempted to link the periodicity of the chemical properties of elements with the periodicity found in the music. Yes, so his classification or segregation of elements is compared with the musical notes in the music. In the musical scale, any note in a key is separated from its octave by interval of 7 notes, isn't it? For example, if you see the musical notes sa, re, ga, ma, pa, da, ni, sa. So the first note is sa, and even the eighth one is also the same sa again. In the same way, in elements also, when written in the increasing order of their atomic weights, the properties of the first element are resembling with the consecutive eighth element. This must have made him to force all the elements into this octave pattern, sometimes without caring the similarities. So by comparing with the musical notes, he classified elements. Even though certain elements are being dissimilar in the properties, he arranged them in the octave set. Okay, that's a major drawback we can say in the Newland's octaves. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos.